The memory of the yellow sun fades by the day, kept alive more in story and common description than in our visual observations. Most people would tell you the sun actually looks white when it reaches any significant measure above the horizon. The visible appearance of the sun is a function of two things: the emission of the sun and the lenses through which we view it. Those lenses include things like our eyes, the atmosphere, the ionic layers at the top of the sky. When it comes to the sun's emission, this is different than reflection. When a shirt looks yellow, that's because it is absorbing every color except yellow and reflecting those photons back to your eyes. But emission is different, and the sun's actual color is white. This is a combination of its emitted wavelengths and its temperature. The sun emits all visible colors, but blue and violet and green are filtered well by the atmosphere, leaving the yellows and the oranges to dominate, or at least that's how it used to be. Interesting FYI, the most powerful visible wavelength emission of the sun is actually green. More towards yellow-green than blue-green, sure, but still, green. What we see is also a function of its black body radiation, however, and this can be visualized when you see the colors of a flame change as they get further from the source and drop in temperature, which is the same reason why stars in the sky look the way they do. It's more about how hot they are than their preferred wavelength of emission. But our star is starting to look more white, even here from the ground, so bright it wears a crown at the top of the sky. Have you noticed? Have you noticed early springs and midsummer struggles with your plants? Those with sensitive skin might have noticed burning faster, more easily, and at earlier or later times in the day. None of these are coincidence, and indeed, the filter, the lenses through which we view the sun and the heavens, are changing. Earth's magnetic field, weakened slightly from its peak thousands of years ago, to meet a rapid shifting paradigm that resulted in 10% of the field lost from 1859 to about 2000. Then that number was updated to 15% just a decade later in 2010, and the leader of that mission from the ESA said the magnetic field is readying to flip, that we'd accelerated to 5% field loss per decade rather than per century. This loss of the field is a change in the outermost electromagnetic shield of the planet, through which the electromagnetic light waves are passing to get to our eyes. That changes the interaction of the upper atmosphere and ionosphere and changes their altitude, density, and chemical composition. We are losing our planetary shield against electromagnetism from space, and the white sun screams that indeed more electromagnetism is getting in. Now, to review that bit about the magnetic field loss, as the magnetic poles are shifting, the key aspect here is the strength, or loss of strength, of the field. We crept along at near peak strength for a while, and then began tanking 2 centuries ago, accelerating further and further, and now they have pretty much stopped updating that loss rate and the total percentage down. Since the 2017 acceleration, centered over the Pacific LLSVP, the field seems utterly mum on the numbers. But by the way, the changes on Earth are accompanied by similar changes on other planets and on the Sun. And speaking of how the Sun looks, the changes that come next are going to be a bit unnerving, so it may help to get acquainted now. From the changes on Earth to the planets to the Sun, and the known cycle and what to expect. Click the disaster playlist underneath the video or on our channel homepage. Subscribe, and we'll see you in the morning for the daily update. Be safe, everyone.